So to give you an overview of where we are and where we're going, we're coming to the close of what we need to talk about in terms of chemistry's new materials. So what remains is we're going to talk today about oxidation number. Tomorrow we'll talk about how things form compounds. And then we'll finish up by talking about how we determine the molecular mass of a compound. So we're looking at a quiz next week, mid to end of the week, next week. So we already you guys kind of figured this out a little bit, what we're about to talk about today. When we were doing our electron dot diagrams, we talked about this. And from what we talked about, we sort of came up with this octet rule. And the octet rule in terms of atoms is that usually atoms would like to have a full outer shell of electrons. Full outer shell. Now usually that's 8, but it actually can be a different number. But they like to have full electron shells. That makes them, we could say, more stable. And so most atoms of an element do not have full outer shells. Which elements do have full outer shells? The noble gases. Everything else on that periodic table doesn't have a full outer shell. So elements will combine with other elements to actually fill up their outer shells so that they all are stable. And we talked about this with water and salt the other day. We were talking about the electron dot diagrams. So when we make our electron dot diagrams, we place the outer valence electrons around. So hydrogen has how many outer valence electrons? Just one. So hydrogen has one outer electron. What about oxygen? Okay, periodic table. 6. So how many does oxygen want? Wants to get 2 more. Where can it get them? From the hydrogen. It can actually share them with hydrogen. So we have 6. The X's represent the electrons from oxygen. There's 6 of them. There's 6 of them. The hydrogen each has a single electron. And so now these hydrogens have 2 in their outer shell. That's good, because that's all the first shell can hold, 2 electrons. So now the hydrogens are full. The oxygen is up to 8, because it's sharing these electrons. The oxygen is stable, and so we have a stable compound. What do we call it? Water. Water. We have H2O. So 2 hydrogens bond together with 1 oxygen atom, and that forms water. Sodium and chlorine. How many in sodium's valence electron? 8? 1. Chlorine? 7. And again, sodium and chlorine often bond together because the sodium can donate this extra electron to chlorine. And that gives chlorine 8. And since sodium has sort of gotten rid of its electron, what's the next shell below that?
2.
It has 2. Look at sodium on your shell. It's 2, 8, 1. So it gets rid of the 1. The next shell down is 8. That's full. It's happy. So again, both of these elements are happy, and we form the ionic compound sodium chloride. So carbon and oxygen. Again, oxygen. Carbon has 4 electrons. So what's it looking for? 4 more. Okay, and it can get those by sharing with 2 oxygens. Okay, the 2 oxygens share 2 electrons with each carbon. And what do we have? CO2. Carbon dioxide. Again. Carbon can either get rid of electrons or gain electrons to get up to a full outer shell. So all atoms want to be stable. And stable is having 8 electrons in its outer shell or having a full outer shell. And that can happen by gaining electrons to get up to 8, or losing electrons to strip away the outer layer and then have a full outer shell below it. And generally atoms will do whatever is sort of easiest. So if something has 1 electron in its outer shell, how can it get full? There's 2 ways.
Give one away.
Give 1 away, that's pretty easy. Or, what would the alternate be? Right? Not adding 1 wouldn't fill it up. Adding 7 would fill it up. That's more difficult, to add 7 extra electrons. So generally, an atom that has 1 or 2 or 3 electrons in its outer shell, the easiest thing is just get rid of those. Anything with 5 or 6 or 7, the easiest thing is to gain electrons to get up to 8. So atoms form compounds in those ways. So we use this information to talk about what we sometimes call the oxidation or valence number of an element. So those outermost electrons are called the valence electrons. And if you look on your periodic table, everything in one group has the same number of valence electrons. Everything in group 1, how many outer electrons do they have?
1.
They all have 1. Everything in group 2, how many do they have? 2. So elements in the same group generally have the same number of valence electrons. There are some exceptions. Yeah, there are some exceptions. Okay, so they're found in the outermost shell. Now sometimes the periodic table will give you the oxidation number. I know in some of our notes earlier we had those plus and minus numbers that we never talked about. Those are the oxidation numbers. And we'll talk about where they come from in a minute. Dean?
What is the electron shells for bromine pointing to? 7?
Why is it what?
The bromine, what's the electron shells pointing to? 7?
Oh, it's just pointing, that's what this numbers
Oh,
are.
okay.
The series of numbers at the bottom are the electron shells, the electron configuration. All right. So how do we figure out these oxidation numbers? Well, it's pretty simple, actually. First, we look at the outermost energy level. And sodium has 1 valence electron. So what would it like to do to become stable? Joey?
Lose that.
Lose it. So think of it this way. It has 1 extra electron. So its oxidation number is +1. It has 1 extra electron that it would love to get rid of. Chlorine. How many valence electrons, Grace?
7.
7. What would it love to do? Add 1. So its oxidation number is -1 because think of it this way, it's missing 1 electron. If it could fill in that missing electron, it would be happy. So its oxidation number is -1. Carbon. Carbon's a little strange. Because how many valence electrons does carbon have? 4. So it's just as easy to gain 4 as it is to lose 4. So carbon could be a +4 or -4. What's gallium's oxidation number? Raise your hand if you could tell me. You've gone over it. Grady?
3.
Gotta give me a sign with it.
Oh, and the bottom percentage, or,
Yeah, give me a plus or minus.
oh, a plus.
+3. It has 3 extra, +3 electrons that it would love to lose. All right, last slide here. So, who can tell me potassium? How many valence electrons? Brian? 1. What's its oxidation number then? Francesca?
Oh, it would be -1?
No, because it has one extra that it would like to get rid of. So think about the plus like extra, +1. How many valence electrons calcium have, Grace?
2.
2 electrons. What would its oxidation number be? Jake? +2. It has 2 extra electrons. Lead. Pb. How many valence electrons for lead? Joey?
4.
4. So what about oxidation number then?
+4 or -4?
It could be +4, it could be -4. Krypton? Dean?
8.
8. So what do you think its oxidation number is?
0.
0. Then lastly, phosphorus. Taylor?
5.
5 outer electrons, 5 valence electrons. What does that make its oxidation number, Taylor?
-5.
Not -5. How many is it missing?
3.
3. -3. So missing 3 electrons to get up to 8 to have that full outer shell of electrons. Does that make sense? All right. So tomorrow we'll talk about how these numbers are used to figure out what compounds will be formed by different elements.